Hi everyone. Today we're looking at topic 1 in unit 10 on solutions. And if you're sitting down to work on assignment number 1, you'll see it's on polarity, intermolecular forces, and vapor pressure, such as the stuff you see on table H. And looking at assignment 1, I see some really important vocabulary sticking out. Things like nonpolar, attraction for electrons in a chemical bond, vapor pressure, boiling point, and intermolecular forces. And all of these concepts really stem from a couple basic ideas, and we'll just walk through those today. Make sure you have a good understanding of them before you try and tackle this particular assignment. So the two key ideas that all of this stuff bridges on is the idea of electronegativity and symmetry. Because polarity, remember we said, is this idea of unevenness, the creation of a positive and a negative charge, either in a bond or in a molecule. So if we focus in on electronegativity, what we're going to see is that unevenness in electronegativity is what creates a polar bond. That is to say, one of the atoms pulls stronger on electrons in the chemical bond than the other. So this first example of bromine, Br2, it's a molecule with only one bond in it. So we can look at it from this perspective of electronegativity only. Since both bromines pull with the same amount of attraction for the electrons that they share, we see no difference in electronegativity. This is a non-polar bond. The bond shared between carbon and oxygen, though, we see that oxygen has a higher electronegativity value. So it likes to pull electrons over to its side. And when that happens, we see that there's this unfair sharing of electrons, where the difference in electronegativity here is 0.8. Whenever that difference is above 0, you've got yourself a polar bond. Now, not all molecules are only made of one bond. Some molecules are made of several different atoms, things like water or CBr4. We test for their polarity using the idea of symmetry. If things are symmetrical, we should be able to draw two or more lines on it to show that it's the same on the left and the right, or the top and the bottom. Because if it is, there can't be any area of positive or negative charge. So looking at water, that's certainly true if I draw my line straight up and down. But when I go for that second line from left to right, I see that it's uneven or asymmetrical, making this a polar molecule. Looking at CBr4, though, I know that the bond between C and Br is polar. Bromine pulls harder on electrons than carbon does. But when I look at the molecule as a whole and say, tell me about this entire thing, I'm going to draw my two lines on there and see that it's symmetrical, regardless of which way you look at it. So what that tells me is that the electrons are distributed evenly in this molecule so that there is no positive side and no negative side. It's completely symmetrical, making it a nonpolar molecule. And this idea of molecular symmetry and molecular polarity or nonpolarity in particular plays a huge role in determining the properties of the molecule itself. In particular, this idea of stickiness. When a molecule is sticky, that means it has a reason to be attracted to something else. And polarity provides a great reason for attractiveness. And that leads us to the concept of intermolecular forces, or IMFs. IMFs are forces that act between molecules that show an attraction for, let's say, a negative thing to a positive thing. These two molecules are notably attracted to one another because negative attracts positive. It's going to be very hard to rip these two molecules apart. So we say it has strong intermolecular forces. And because it has these positive and negative ends, where'd that come from? Well, it was from a polar molecule. Over here, where I don't have a positive and negative end, I've got a nonpolar molecule, and you'll notice there's no real reason for them to be attracted to one another. There may be some bumping and shuffling amongst themselves, but these are weak IMFs that arise as a result of no positive and negative to attract, like magnets. There's nothing there, so these intermolecular forces are going to be quite weak. You can use the concept of intermolecular forces to explain two key physical properties of liquids: vapor pressure and boiling point. And if you remember in class, we talked about vapor pressure being the pressure, which provides the pressure. The pressure provided by these gas molecules that sit on top of liquids. Different liquids have different amounts of gas sitting on the top of them. Polar liquids tend to want to stick to one another. So it's going to be very hard to pull molecules out of the liquid phase into the gas phase for a polar substance. So we tend to see low vapor pressure for polar substances. These are so attracted to one another, they don't want to let anything escape. Nonpolar substances, on the other hand, aren't so attracted to one another. So when you throw them into a liquid state, it's easy for molecules to kind of slip out as gases and sit there above your liquid phase. So we see high vapor pressure, or a lot of vapor, for these nonpolar substances, which is why so many of them tend to be stinky and very unpleasant and usually quite unhealthy. High vapor pressure comes as a result of a lack of attraction between the liquid molecules themselves. And as you can imagine, you can carry this idea over to the concept of boiling point. When we boil something, we have to rip apart its intermolecular forces, right, to change it from a liquid phase into a gas phase, which we assume has no attractions. Things that are polar, like we've said, have this strong attraction for one another. So it's going to be very, very hard to get a polar molecule to boil. Let's say this liquid happened to be water. We know water, since it has an H and an O bonded to itself, has the capacity to hydrogen bond. Hydrogen bonds are very strong intermolecular forces, and if you're going to try and boil water, you've got to completely overcome those hydrogen bonds. That's going to be very, very difficult. So we see H2O has a relatively high boiling point for a molecule of its size. If you look at something like CH4, it also contains hydrogen, but it doesn't have those magical elements FO or N to enable it to hydrogen bond. This is also a nonpolar molecule, so we don't see the same kind of attractions between molecules. It's much easier to break apart the intermolecular forces because they're hardly there in the first place. CH4 has an incredibly low boiling point as a result. So think carefully about, how did electronegativity, how did symmetry affect whether I classified a molecule as polar or nonpolar? Oftentimes you're going to need to draw a diagram to make that distinction. And then consider how polarity is affecting the physical properties of the substance you have. And always bring it back to this idea of attraction between positive things and negative things. If after you complete assignment 1, you're still feeling confused about this whole polarity and intermolecular force thing, please do take the time to come make an appointment with me during homeroom or after school or before school or any free time that you have during the day to get this sorted out, because you're going to find that polarity haunts you through the rest of this unit and through the remaining units of the year. So now is a great time to get it all figured out. So come see me or another chemistry teacher if you've got lingering questions that need to be answered.